Okay, so let's continue our discussion about blood. We had mentioned before that there are granulocytes and agranulocytes, and that the granulocytes included the neutrophils, eosinophils, and basophils, and that the agranulocytes included the monocytes and the lymphocytes. So now we'll talk a little bit more about the characteristics of each. The granulocytes have granules in their cytoplasm, and they can be stained, and that includes, again, the neutrophils, eosinophils, and basophils. The agranulocytes lack any kind of granules, and that includes the lymphocytes and the monocytes. Now, the relative concentration of these, the way that what's highest to lowest, is relevant to us just in if there's a test done called a CBC and diff. That's a complete blood count with differential. And an elevated number of one or more of these elements could give us a clue as to what kind of infection a person had. Now, I'm not going to ask that you know neutrophils, lymphocytes, monocytes, eosinophils, basophils in that order. If you want to, there is a mnemonic: never let monkeys eat bananas. Um, but if that order were changed up, if we had a higher level of basophils than eosinophils, or a higher level of eosinophils than monocytes, and if we had elevated eosinophils, we might have a infection of some sort of parasite. If we had an elevated quantity of basophils, we might have an allergic reaction that was going on. But a little bit about each of these. The neutrophils are phagocytic. They are the first ones to go to the site of an infection or tissue damage. They are active at the site of that infection. Eosinophils, these are large, kind of brick red cytoplasmic granules, and they are found in response to allergies and parasitic worms. So if I were to ask a test question which said, which one of these is associated with parasitic worms, the answer would be eosinophils. On the other hand, when we look at basophils, they are also found in response to allergic reactions. So if I said which of these is associated with allergic reactions, the answer would be both eosinophils and basophils. Now, basophils release histamine, and they are involved in the initiation of an inflammatory response. Again, they are also found in allergic responses. These cells come from a stem cell that's called a hemocytoblast. Now, I don't care that you know hemocytoblast, but there are two subgroups, lymphoid cells and myeloid stem cells. The lymphoid stem cells make lymphocytes. That's B and T cells. All of the other cells, the erythrocytes, the platelets, monocytes, neutrophils, all of that come from myeloid cells. Now, types of agranulocytes. Those are our lymphocytes, the B and T cells, and they are important in immune responses, just as are the granulocytes, but these play a more specific role. The granulocytes are more a generic response. But B and T cells play an important role. B cells make certain proteins in our bloodstream that are known as antibodies. And these antibodies can bind to foreign bodies, foreign objects, and neutralize them or initiate some other immune response. T cells, these are directly involved. So while the B cells make these antibodies, the B cells never actually encounter the foreign body. The T cells have a variety of roles. They can go out and actively hunt cells that are foreign to us. They are kind of like the foot soldiers. They can go through our bodies and look for stuff that does not belong to us and kill anything that just looks weird. There are helper T cells, there are memory T cells. So the T cells have a variety of roles. We also have the monocytes, Again, these are the largest of the white blood cells, and they function as macrophages. Once they exit the bloodstream, they go in and they gobble up anything that's foreign. They are also located in lymph nodes and are involved in some interactions between T cells and B cells. But monocytes we see in fighting chronic infections. So someone who has had an infection for a while, whether it's a cyst or a boil or tuberculosis, what you're going to look at inside those tissues are monocytes. Now, platelets, these are cell fragments. They're not cellular. They are, again, bags of chemicals. They are derived from a large cell called a megakaryocyte. They are needed for the clotting process. And when you take aspirin, you can actually inactivate or at least diminish the capacity of platelets to form a clot. So people with certain heart problems or people who are prone to certain types of strokes may be instructed to take a small, 85 milligram aspirin a day or 81 milligram aspirin a day. The process of stopping blood flow is actually, whoop, my bad here. Let's go back and talk about hematopoiesis. This is forming of blood cells, and it occurs in red bone marrow. All the cells actually are from red bone marrow. They're derived from that common stem cell, like I said, lymphoid or myeloid cells, but the making of cells is hematopoiesis. Control of this is by hormones. There is a hormone that is released by the kidney called erythropoietin. Now, the kidney receives 25% of your blood flow, so it is a great place to evaluate the quality of the blood. And if there is an insufficient oxygen content in the blood, the kidneys will produce this erythropoietin, which will increase the amount of red blood cell production. So this is a homeostatic mechanism. It's negative feedback. As the red blood cells increase, we hit a certain trigger point and we stop making red blood cells by cutting down on the erythropoietin. So just again, to remind you of how a negative feedback system works, it's this kind of seesaw where we have a tipping point. If we get out of balance, then we trigger or stimulate the production of erythropoietin. The erythropoietin stimulates the red blood cells or red bone marrow to produce more red blood cells, which brings us back into balance. Now, formation of white blood cells, this is also controlled by hormones, but different name. Colony stimulating factor promotes the white blood cells, leukocytes. Thrombopoietin is a stimulus for the production of platelets. Now, you should know these hormones: erythropoietin for red blood cells, colony stimulating factor for white blood cells, and thrombopoietin for platelets. And now we get to talk about the maintenance of red blood cell or maintenance of blood in terms of clotting, which is also known as hemostasis. This is the stoppage of bleeding which results from a break in a blood vessel, cut in a blood vessel, anything like that. Hemostasis involves three basic phases. We have a vascular spasm. That is, that the blood vessels in the area of the damage constrict, that cuts down on the blood flow out of the area. This prevents materials from being carried away from the site. It also allows blood to come in and pool, and we can get some repair mechanism going on. There is a platelet plug that forms, and this is a temporary structure which stops the bleeding. and ultimately coagulation. Now, if coagulation doesn't occur properly, eventually the platelet plug breaks down, the vascular spasm can stop or relax, and so someone can have an injury and not be bleeding, and a half hour later start to bleed. Uh, this graphic just kind of shows you the general steps involved. We have the vascular spasm slowing down blood flow, which allows the platelets to attach to damaged tissue, which releases chemical compounds, which ultimately forms the clot. A couple of things that you should be aware of. Calcium is necessary for this. So an element that must be in the bloodstream for clotting to occur is calcium. In fact, when you donate blood, the way they keep the blood from clotting up in the bag is that they have a chemical that will bind to the calcium in the bloodstream, and as a result that stops that clotting cascade. Now, there are a number of steps involved. Actually, clotting is a rather complex process. It involves a dozen steps, dozens of different factors. So we have the Christmas factor, we have the Easter factor, we have the factor 8, and so on and so forth. So let's keep it fairly simple, though. In the presence of tissue damage, uh, there is a release of some chemicals, which, along with calcium, causes the formation of prothrombin activator. Prothrombin activator helps convert prothrombin to thrombin. Thrombin helps convert fibrinogen, which is a soluble protein, into fibrin, which forms a meshwork that holds the clot together. So, a little bit about each then. Vascular spasm. Vasoconstriction causes blood vessel to spasm. Spasm narrows the blood vessel, decreasing blood loss. The platelet plug forms, and the way the plug forms is that platelets will bind to exposed collagen. We talked in earlier chapters about how we have epithelial tissue that lines all surfaces. Well, one of the reasons is that platelets don't stick to epithelium. They do stick to the collagen in the connective tissue below. So if you have a damaged vessel and you have exposed collagen, platelets will stick to that and cling to those fibers. And they will burst open, which releases chemicals, which will attract more platelets to the area, and you will get this pile up of platelets and this plug formation. Again, we've looked at this. Platelets release chemicals. This tissue factor in presence of calcium, formation of prothrombin activator, prothrombin, thrombin, fibrinogen, fibrin. Just be aware of those steps. We are leaving out actually quite a few of the chemical intermediaries. But the end result is that once that meshwork of fibrin forms, we have coagulation. We have a clot form. And let's see. Well, that just kind of goes over materials we've already said. Thrombin joins fibrinogen. It makes these hair-like molecules of fibrin. Fibrin forms that meshwork, which is the clot. And we usually clot within 3 to 6 minutes. Again, if you were to take aspirin, your bleeding time might be extended. The clot will remain until the epithelial tissue reconnects, that is, regenerates. Epithelial tissue touches epithelial tissue, and until we've gotten cells that connect all the way across, we will have this clot. There is a mechanism in our bloodstream to break down the clot after tissue repair has occurred. This is a fibrinolytic system, which means just that it is breaking down the fibrin. And if you were to see a clot form, you would see something like this. Now, this is color enhanced, but you can see that these are red blood cells, and you can see this meshwork of fibrin interlacing this and holding it all together. at this point, we will stop and we will pick up again with a discussion on some of the undesirable types of clotting that can occur in your bloodstream. Thank you much.